Bermuda's hidden gem. Scientists uncover a massive underground structure unlike anything else on Earth. Scientists have uncovered a mind blending geological mystery beneath Bermuda, one that rivals and perhaps surpasses the island's legendary supernatural reputation. Beneath the Atlantic waves and under the island's ocean crust lies a colossal stone structure that researchers say is unlike anything else on Earth. Now let's dig in and break this story wide open on the AI podcast.
Deep dive. Today we're focusing on an island that's, famous for its mythology, Bermuda. For decades, when you mention Bermuda, the first thing people think of is the Bermuda Triangle, vanished ships, lost planes.
Right. Centuries of folklore about magnetic anomalies and curses. It's a place where the mystery has almost completely overshadowed the reality.
It really has.
The legends are great for tourism, I'm sure, but they've obscured some truly world-class scientific questions that geologists have been wrestling with for a long, long time.
Exactly. And what we found in the sources is that the scientific truths about Bermuda, what's happening deep underground and what's really dangerous on the surface, are just so much more extraordinary than any story.
We're talking about colossal geological forces. Ocean physics so violent they make the legends feel, well, almost pain.
Right. So our mission today is to cut through that folklore and get into the hard data. We've got two sets of scientific investigations to unpack for you.
First, we need to understand this fundamental paradox of Bermuda's existence and how scientists finally found this gigantic buoyant structure that's basically keeping the island afloat.
And second, we'll shift from the deep Earth to the chaotic ocean surface. We're going to get into the rational but genuinely terrifying scientific reason for those infamous disappearances.
So this deep dive is really your shortcut to understanding why Bermuda is one of the most geologically unique and naturally dangerous places on the planet.
Okay, let's start with that geological puzzle. To really get the scope of this discovery, we have to start with the question that just vexed geologists for decades. Why does Bermuda even exist where it does?
Well, it's sitting on what scientists call an oceanic swell, a huge raised patch of the oceanic crust.
And normally when we see a swell like that, it's because of active heat from below.
Exactly. You'd expect a volcanic plume or a mantle hotspot, kind of like what you see under Hawaii. That heat keeps the crust less dense, so it, floats higher.
But Bermuda is the geological equivalent of finding a giant ice cube in the tropics that just never melts.
Yeah, that's a good way to put it.
The paradox is, one, Bermuda is old. It's been volcanically inactive for over 31 million years.
And two, any normal volcanic swell that old should have cooled down, contracted, and just sunk back into the seafloor millions of years ago.
It should be gone.
It should be completely gone. But it isn't. Bermuda is still strikingly elevated, about 500 meters, that's 1,640 feet, above the surrounding deep ocean floor.
That's an immense amount of material to be held up. To put that 500 meters in perspective for you, that's taller than the Empire State Building.
And it's being held up by some invisible permanent force.
So if it's not current volcanic heat, it means the structure itself, deep down, has to be fundamentally different from anything else we've ever mapped?
Precisely. That was the classic geological problem. And the answer, as the source material from Carnegie Science shows, lies about 31 miles or 50 kilometers right beneath the island.
So how did they even map something that deep?
They used passive seismic recordings. So basically, they just waited for earthquakes to happen elsewhere in the world.
Oh, okay.
And then they listened to the echoes of those seismic waves as they traveled under Bermuda. It creates a sort of ultra-deep sonar image.
And what they found was, what, staggering?
Oh, completely. The analysis revealed this colossal structure, an incredibly thick layer of rock that's 12.4 miles thick, that's 20 kilometers, just sitting right under the island.
We need to give you a sense of scale here because 12.4 miles of extra rock sounds like a lot, but what does that actually mean?
It means Bermuda's structure is, well, it's virtually unique. Typical oceanic crust, the stuff that makes up the entire Atlantic seafloor, is usually only 5 to 10 kilometers thick.
So this is 2 to 4 times thicker than normal?
Yes, and it's an extra component, a massive solidified slab that has become a permanent part of the tectonic plate.
That's the key distinction, isn't it? It's not just a bump on the crust. It's a whole other layer that shouldn't be there.
Exactly. The seismologist on the study, Dr. William Fraser, he put it this way. Typically, you have the bottom of the oceanic crust, and then you would expect the mantle.
Right.
But in Bermuda, there's another layer squeezed beneath the crust embedded directly within the tectonic plate. It's a literal raft of rock.
That phrase, raft of rock, that's where it all clicks into place. This is the missing piece that solves that whole elevation paradox.
Mm-hmm.
So how does a 31-million-year-old piece of frozen rock still keep the island uplifted?
It all comes down to buoyancy, but it's buoyancy based on composition, not on heat. The theory is that during Bermuda's last volcanic cycle, huge amounts of magma forced their way into the crust, but then they stalled.
It got stuck.
They got stuck. Instead of erupting, they just froze there, creating this incredibly thick, massive internal body.
So it's not the mantle pushing it up from below anymore. It's this specific frozen chunk acting as a permanent internal support.
Exactly. But you ask why it's still buoyant. Surely all rock is heavy.
Right.
Well, all rock is heavy, but not all rock has the same density. The magma that formed this raft was unique. It froze into rock that is fundamentally less dense than the material of the deep mantle around it.
So it's like a piece of styrofoam embedded in concrete.
That's the perfect analogy. That density difference is permanent, it's structural. So this raft, being less dense than what it's sitting on, just acts like a giant subsurface cork. It's permanently buoying the island up to that 500-meter elevation.
And it doesn't matter how cold or old it gets.
Doesn't matter at all.
That makes so much sense. The isler's weight is just permanently compensated for by this massive buoyant slab inside the crust. But that raises another question. Where did this unique light magma even come from?
This is where it gets really interesting, because this connects Bermuda way back to Earth's ancient history. Previous studies of Bermuda's lava flows had already shown something was weird.
Okay.
They found unusually low amounts of certain elements like silicon and carbon. And that was a critical clue.
Why does that specific low element count matter so much?
Because that chemical signature, low silicon, low carbon, it doesn't match magma from a typical shallow mantle hotspot, like the one that's feeding Hawaii right now.
A deep, undisturbed source, then.
A very deep, primordial source. The theory now is that this source was exposed and tapped way back when the supercontinent Pangaea started splitting apart. We're talking about events between 900 and 300 million years ago.
Oh.
That unique magma was forced up during that extreme continental breakup, and when it stalled and froze, it created this permanent, buoyant platform.
So Bermuda isn't just a simple volcano. Its very existence is rooted in a specific, unique event tied to the mechanics of Pangaea fracturing.
Exactly. It created a 12.4-mile thick slab of low-density rock that has effectively defied geological gravity for 31 million years.
And that has huge implications for future research, doesn't it? I mean, if this mechanism exists, is Bermuda really a one-off?
That's the big question. Or are there other geological anomalies out there, other islands, undersea plateaus, that are actually being held up by hidden frozen rafts from the Pangaea era that we just haven't found yet?
That's a profound thought. That whole sections of the Earth's crust might be supported by these ancient frozen plumbing systems we're only now starting to map.
Yeah.
Okay, let's pivot now. From the mystery of the deep Earth to the mystery of the surface. Bermuda's geology is astounding, but its fame, well, it comes from the terror of the Bermuda Triangle.
That region roughly defined by Bermuda, Florida, and Puerto Rico. And the legend is powerful.
Oh, yeah.
Hundreds of ships and aircraft reportedly vanish without a trace. The folklore suggests everything from, aliens to magnetic vortices.
But the sources we've gathered confirm that the solution, according to oceanographers, is entirely scientific. The truth is much simpler, but just as terrifying for anyone out on the water.
The scientific explanation is rogue waves.
Now, when we say rogue wave, people often picture just a really big storm wave, but these are fundamentally different, aren't they?
They are. They're defined by their sheer scale and their total unpredictability. We're talking about massive, almost vertical walls of water that appear from nowhere.
So independent of the weather.
Largely independent of the prevailing wave patterns, yes. An oceanographer, Dr. Simon Boxall from the University of Southampton, he details their power.
So give us the scale. How big are we talking?
We're talking up to 100 feet, that's 30 meters, is double the height of the surrounding storm waves.
Double.
The physics behind it is called constructive interference. It's what happens when multiple different waves coming from different directions or at different speeds converge perfectly at a single point.
And their energies combine instead of canceling out.
They combine to form one monstrous peak.
Right.
And that sudden, massive peak is the key to disaster.
Because a large ship is designed to handle big waves from the front. But if a 100-foot wall of water hits it from the side...
The consequences are catastrophic. Absolutely devastating. The forces are unimaginable. Dr. Boxall explains that a ship caught in a rogue wave could be overwhelmed and sink in an incredibly short time.
How short?
2 to 3 minutes.
2 to 3 minutes. That time frame completely aligns with the historical record of disappearances in the Triangle, doesn't it?
It does. If a ship sinks that fast, there's no time to get a distress signal out. No time for lifeboats.
And any wreckage would be scattered and destroyed by the turbulence.
It leaves behind no trace. Only the silence that has fueled all those supernatural legends for generations. The sudden, total disappearance is actually a feature of the rational, physics-based explanation.
But why are they so frequent in the Bermuda Triangle specifically? That area isn't necessarily famous for having the world's worst storms all the time.
It's the convergence zone. The triangle is a unique geographical intersection where the warm waters of the Gulf Stream collide forcefully with the cooler North Atlantic current.
So you have all this clashing energy.
You have a highly energetic, turbulent environment where multiple different wave trains are constantly running into each other. It's the perfect physical storm for constructive interference to happen.
It makes a random event much more likely.
Statistically, much more likely than in the calmer open ocean, yes.
So what does this all mean? We've taken this deep dive into Bermuda, and we've seen that science is steadily peeling away all the layers of mystery. But the underlying scientific realities are just. They're far more compelling than the folklore.
The true story is that Bermuda is being held up by a buoyant 12.4-mile raft of ancient rock, a relic of the Pangea breakup. And the reason for the disappearances is the extreme, terrifying reality of rogue waves.
It really shows that we often invent these extraordinary reasons for events when the truly extraordinary natural forces, whether it's deep Earth forces defying gravity for 31 million years, or ocean physics creating 100-foot walls of water, are just staring us right in the face.
And this dive has really reshaped our understanding of island formation. It proves that the structure of our oceanic plates is far more complex than the simple crust mantle layer cake.
And as we close, the revelation that a massive buoyant structure is responsible for an island's existence raises an important question for you to mull over. If ancient frozen magma can provide permanent support beneath Bermuda, how many other seemingly stable coastal regions or islands around the globe are actually being held up by hidden buoyant rafts we just haven't mapped yet? And what might happen if those stabilizing structures ever shift?
The biggest mysteries really are the ones right beneath our feet. Thanks for diving deep with us.
Okay, one question for you. What does the newly discovered rock layer beneath Bermuda reveal about the island's mysterious elevation? Don't forget to comment it. Thanks.